Okay then, now let's turn our attention to a special type of trigonometric expression. It actually looks like a sine x plus b cos x. Yes, in here a and b are some real constants, okay, and obviously x varies over the set of all reals. I am interested in finding the minimum and the maximum value of such a function. This function is actually kind of a linear combination of the sine and the cosine function. So what am I interested in? I'm actually interested in finding the minimum and the maximum value of this function. Let's call it f of x for convenience. Or in other words, computing min and max of a function is kind of equivalent to computing the range of the function. Okay, so I am actually interested in getting the range of this function. So let's see how to get the range of such a function, which we are for convenience calling as f of x. See, the very first step you have to do is consider f of x, which is equal to a sine x plus b cos x. And what you know, multiply and divide by under root a square plus b square. You do that deliberately. Why? You'll understand. Multiply and divide by under root a square plus b square. Now, one thing you please understand, of course, I am not allowing a and b to simultaneously be equal to 0, because otherwise this will be 0, this will be 0. That means my entire function will be 0, which is a redundant scenario. Cool. So a and b are not both simultaneously equal to 0. That means a square plus b square is certainly positive. So under root a square plus b square is positive. That's why it's giving me a guarantee that yes, I can divide by under root a square plus b square, and to balance it out, I'm multiplying by under root a square plus b square also. Okay. Now you know what? This is what my expression gets converted into. Cool. Fine. Not a problem. What I'm going to do now is something extremely smart. If I consider a right angled triangle with one side length as A and other as B, then obviously the hypotenuse is going to come out to be under root A square plus B square. That's but obvious. This is my right angle triangle, right angled at C, and my hypotenuse obviously is coming out to be under root A square plus B square. Now, if I take this to be my acute angle, let's say alpha, then sine alpha is equal to B upon under root A square plus B square. Cool, that's fine. Sine is what? Opposite upon hypotenuse. And similarly, cos alpha is going to be a upon under root a square plus b square. Because what is cos of an angle? It is adjacent upon hypotenuse. That means what? Go back to your expression. I can replace this by sine alpha and replace this by cos alpha. That means this entire expression gets converted to sin x cos alpha plus cos x sin alpha. Is this reminding you of something? Yes. If I replace this with capital A, this with capital B, this actually is nothing but sin A cos B plus cos A sin B, which is nothing but sine of A plus B. That means this entire expression gets boiled down to sine of x plus alpha. Now understand what just happened due to all these steps. My original f of x, which looked like a sin x plus b cos x, is now coming out to be equal to under root a square plus b square times sine of x plus alpha. Because both these are actually same, that's why we are going to actually compute the range or the min and max for this particular function. How? Let me tell you. See, please recall that no matter what real angle theta is, no matter what real angle theta is, sine theta is always between -1 and 1. Yes. Now I told you x is varying over real numbers. So x is real, alpha is real, definitely x plus alpha is also real. So sine of x plus alpha will also be sandwiched between -1 and 1. Yes, do you agree? Now I already told you under root a square plus b square is strictly positive. So what you do now is you multiply throughout in this inequality. You multiply throughout by under root a square plus b square. That will not disturb the sign of the inequality because we are multiplying by a strictly positive term. Cool. What happens in the next step? You end up getting under root a square plus b square times sine of x plus alpha is greater than equal to minus of under root a square plus b square and less than equal to plus under root a square plus b square. Do not forget, this was your f of x, originally equal to a sine x plus b cos x. So what are you getting actually? You are getting that f of x is at least equal to this. So what is this? This is actually the minimum value of f of x. And you're also getting that f of x is at most equal to this. So this is the maximum value of f of x. Understood? Always remember a sin x plus b cos x is sandwiched between minus under root a square plus b square and plus under root a square plus b square. Which in other words, I can say that range of the function f or range of a sin x plus b cos x is this. Or in other words, I can say is equal to f min, f max, closed interval. What is f min? Minus under root a square plus b square. What is f max? Plus under root a square plus b square. I hope you understood this very, very nicely. There are tremendous applications of this particular result. So let's directly jump on to check out the applications.
For more videos and live lectures on the JEE, click on the subscribe button now.